Howdy students! Today we're going to look at an introduction to ellipses. Now an ellipse basically is an oval shape, though we do have a more precise mathematical definition. An ellipse is the set of all points such that the sum of the distances from a point on the ellipse to two fixed points called the foci, which is the plural of focus, is constant. So what that means is no matter which point we pick on the ellipse, if we look at the distances between that point and the two foci, and we add those two together, the sum is going to be constant. So whatever we get when we add these two distances together, it's the same as if we added these two distances together or these two distances together. Basically, if we start at one of the foci and go straight out to a point on the ellipse, and then we go straight to the other focus, then that sum is going to be the same no matter which point we go to. And what we're going to do is we're going to use this property to come up with an equation that gives us the graph of the ellipse. Now there's going to be quite a lot of algebra involved in this video. It's going to be very, very heavy, a lot of calculations, but in the end, we're going to end up with the standard form of an equation for an ellipse, just like we've had the standard forms before for parabolas and for circles and things like that. And once we have that, we're not going to need to go back and do all of this algebra again. So I don't want you to worry if this algebra ends up being quite a lot of work, because you're never going to have to do this again. We're just doing this once so that we can get the formula. So what we're going to do first is we're going to label our points F1 and F2. We're going to say that these points have coordinates c, 0 and negative c, 0. Basically, we're going to start with an ellipse that's centered at the origin, and we're going to look at the two foci that are to the right and to the left of the origin. We're also going to label a generic point on the ellipse with coordinates x, y, and we need to define what the sum of these distances is going to be. And we're going to let that sum be 2 times the letter A, which we could let this be anything, but we're going to do that because it's going to make our lives easier. So what we're going to say is that the distance between F1 and our point P plus the distance between F2 and our point P, we know that it has to be constant, and we're going to call this constant 2a, which you'll see in a little bit is going to make things easier. So we can actually use the distance formula to express these distances. We know the distance formula is going to be the square root of the difference in the x coordinates. So here it's going to be x minus c squared plus the difference in the y coordinates, and that's just going to be y squared because one of the y coordinates is 0. And let's make that square root symbol a little shorter. And then plus the other distance, that's going to be x plus c squared plus y squared. It's x plus c because it's x minus negative c. And we know that the sum of these two distances has to be 2a. Now, this is kind of a mess, particularly because we have these two different square roots. So what we're going to do is we're going to work a little bit of algebra magic to make this nicer. And we're going to start by subtracting this square root from both sides. When we do that, we're left with the other square root on the left. And then on the right-hand side, we've got 2a minus that other square root. And then what we're going to do is we're going to square both sides to get rid of this square root. Now when we square the left-hand side, squaring a square root gets rid of it. So we've got x minus c squared plus y squared on the left. But on the right, we're not actually going to get rid of this square root in its entirety by squaring it. And the reason is because we've got a subtraction here. So this is like a binomial that's squaring, being squared. And so we've got to take the first term and square it, minus 2 times the product, plus the last term and square it. So that's going to be 4a squared minus twice the product. 2 times 2a times that square root is going to be 4a times that square root. And then plus the last term squared. And there, when we square the square root, we're going to cancel them out and get x plus c squared plus y squared. Now, this looks nasty, but we're going to have a lot of things cancel, and things are going to be good. So if we take this x minus c on the left and we square it all out, we're going to get x squared minus 2cx plus c squared. And then we're going to do the same thing on the right-hand side. Once I get there, this is going to be x squared plus 2cx plus c squared plus y squared. And we have some things that cancel, which we can cancel by subtracting from both sides. We've got the x squared on both sides. We've got a c squared. We've got a y squared on both sides. So we can subtract all of those from both sides. And when we do that, this leaves us with negative 2cx equals 4a squared minus 4a times this whole square root plus 2cx. And what we're going to do is we're going to move this negative 2cx to the right by adding it, and we're going to take this 4a times the square root and move it to the left by adding it. So when we do this, the 4a squared stays on the right, and then when we add the 2c from the left, when we add 2c to cx to both sides, that gives us 4cx on the right. And when we move that term with the square root to the left, it gives us positive 4a times the square root of x plus c squared plus y squared. Then what we can do is we can divide both sides by 4, and that gives us a times the square root of x plus c squared plus y squared on the left, and then a squared plus cx on the right. And then we're going to square both sides again. When we do that on the left, squaring the a gives a squared, and then squaring the square root cancels the square root, so we're left with x plus c squared plus y squared, getting multiplied by the a squared. And then on the right, when we square this, again, we've got to either use FOIL or we've got to use the special product formula. When we square the first term, we get a to the 4th, plus twice the product of those terms, so plus 2a squared cx, plus the last term squared, c squared x squared. Then on the left, oh, there's so many terms, but we're going to get some cancellations, and life's going to be good. Inside the parentheses on the left, we're going to have x squared plus 2cx plus c squared plus y squared. And then on the right, a to the 4th plus 2a squared cx plus c squared x squared. When we distribute the a squared on the left, we get a squared x squared plus 2a squared cx plus a squared c squared plus, a squared y squared equals a to the 4th plus 2a squared cx plus c squared x squared. And it looks like we've got a 2a squared cx on both sides that we can cancel out. So let's see where we are now. And we're almost there. I'm going to move this up a little bit so that we can work with what we have down here. So what we're going to do next is we're going to try and move some terms around. We're going to move this a squared c squared to the other side. And we're also going to move the c squared x squared to the other side, which is going to seem weird, but we'll get there in just a moment. So if we do that, on the left, we're still going to have the a squared x squared, and we're still going to have the a squared y squared. But then on the right, we're going to have that a to the fourth, and we're going to have a minus a squared c squared, because we've moved this to the other side by subtracting it. Then on the left, we're going to have minus c squared x squared. And what we're going to do is we're actually going to factor out an x squared from those two terms. And we're going to factor out an a squared from those two terms. And we're going to have x squared times a squared minus c squared plus a squared y squared. And then on the right, a squared times a squared minus c squared. And then we are going to divide both sides by a squared times a squared minus c squared. And I'm running out of room here, so I'm going to have to put this, let's go up and to the left. Let's go up over here. So when we do that, this first term, the a squareds minus c squareds cancel out, and we've got x squared over a squared, plus, in the second term, the a squareds cancel out, and we've got y squared over a squared minus c squared. And then on the right, everything cancels out, and we're left with 1, because anything divided by itself is 1. And what we're going to do, for convenience sake, we're going to let b squared represent a squared minus c squared, and we'll talk about that in just a moment. And when we do that, we get something really nice. X squared over a squared plus y squared over b squared equals 1. And this is going to be the standard form for the equation of an ellipse. And this video is already at the 13-minute mark, so what we're going to do is we're going to move to the next video, and we're going to talk about what this means and what A and B represent within the context of our ellipse. And we're going to leave all of this ugly algebra behind us. We're never going to have to look at it again, and we're just going to focus on the simpler format for this equation and what it all means.